All right, so this goes with your magnetism notes. So it is still a part of the same PowerPoint that we did with electricity. This is just going to go over what deals with magnetism. So remember, this week is magnetism, and then next week is your test. So magnetism are the properties and interactions between magnets. Magnetic force is the push or pull of an object with push with like forces and pull with unlike forces. So north, south, positive, negative. Magnets come in different strengths. So the magnets that you see that are around your house, that are on your fridge, they're not going to be the same kind of strength that moves or pushes your faster moving vehicles and what am I trying to say? Oh yeah, the roller coasters, like Six Flags and things like that. And magnetic field is the region that surrounds a space around a magnet which exerts its force on it. So field lines are, of course, they're a lot like the electrical field lines that we looked at. So north and south north pushes away from it, south pulls into it. So every magnet has a north and south end. So the closer together the field lines are, the stronger the magnet. The further apart, the weaker. So magnetic poles are the areas with the strongest force. Magnetic domains are the groups of atoms with their atoms lined up in that cause this magnetic force. So magnetic domains are the atoms moving around in the magnetic field. So magnetized metals pass through a magnetic field and cause more of a stronger magnetic domain. So non-magnetic material have no domains. They're all over the place. Magnetic material domains are not lined up, but in a magnet, they are lined up. So the magnetic material means that it can be grabbed onto by a magnet, or it will have some sort of force where it pulls in there. The magnet itself is lined in a specific direction, so it will. So when we put something on a metal object and that magnet stays there, that's why they stay in one position. The magnetic material will be able to gather in whatever the magnet is bringing. So domains are aligned without aid of an external force in a permanent magnet. So that means that the magnets that hold up the paper on my board or hold up the things on your fridge, these are permanent magnets. So stroking a metal or a cooling metal in a magnetic field can make a permanent magnet. Also, if you look at screwdrivers on the head, because of their uses, will eventually, because you stroke onto a metal method, and it will create that permanent magnet. Electricity and magnetism are very closely related, like we've said before. So Hans Christian Ørsted accidentally found that they were related, having a compass near a wire. So once he put the compass near that electric field, he saw the compass dance a little bit. So put your thumb in the direction of a current and point your fingers in the direction of the magnetic field. So if you were to grab that wire, it's the right hand rule. So you grab it, put your thumb out, that shows you what your magnetic field is. Electromagnetism is a force in which you have a stronger magnetic field and also have an electrical field. So these are the things that help move or create larger systems. So you can have things like the Hadron Collider uses electromagnetism. Electromagnetism is also used with our faster moving roller coasters and planes, computers. So magnetic field around a current carrying a piece of wire is stronger by depending on the shape of a wire. So a solenoid is a single wire wrapped into a coil. That's going to give you a stronger one. Magnet is a temporary magnet created when there is a current around that wrapped coil. So you can create it and turn off the magnetic field with electromagnets. That's how you can have sealed doors, such as the ones at school that we have. So when you have an electric current go through it, it can turn off that seal, or it can turn on that seal. Just depends on what it's using. So you can make an electromagnet rotate by spinning it near your north and south poles. A galvanometer is an instrument that detects small electrical currents. So this is used to see if we can create a magnetic field with electrical currents, or it can be used when we try to find like electrical poles, try to find loose wires that are in an area. Galvanometer will actually work well with that. Ooh. All right, so electric motor. Electric motor is an electrical machine, of course, that you guys know. So you can use Teslas run on electric motors. They convert electrical energy into mechanical energy. So most electrical motors operate through the interaction of the magnets inside of it. So the battery moves the magnets to push through the motor to create the torque which is needed to move the object or to create whatever substance is being used. So if you want to, you can make your own simple motor with the wire here. I'll let you guys watch that. So when we talk about producing electrical current, so electromagnetic induction is generation of electric current by changing the magnetic field. So if you would like to, and I would suggest it, if we click on this link, this goes through and it is a simulation of creating a change in your electromagnetic induction. So if we put our magnet through here, we can see that the voltage either goes from the negative or positive depending on what we are putting through the coil. And you can change it up. So you can see the larger coil is actually giving us a much brighter effect on our light bulb. All right, generators also use electromagnetic energy to transform energy and create the electrical energy. So a alternator is in your car, and a generator, these use the different time frame or the different types of electromagnetic energy to create movement in your engine. Transformers, so these are the things that take alternating current and will increase or decrease our alternating current and the voltage. So that way you don't have an overloading of voltage. So the transformers you see outside, so when you hear a transformer blue, that means that too much voltage was pushed through the transformer and caused the power outage in your area. And that's it for the notes. I know we are a lot quicker today. If you have any questions, please email me. I am available all week. Remember, we only have one live stream this week on Wednesday. And I'll talk to you later.